Hello everyone, welcome to Unacademy ICSE and ISC YouTube channel. So, good evening everyone. I hope everyone is alright. How are you students? Okay. So, hey everyone, this is Manisha, your class 10 chemistry educator. I have done my graduation and diploma and I'm a gold medalist in both. I have 6 years of teaching experience. So today we will be studying your organic chemistry. Today this class is on organic chemistry, basically on hydrocarbons. And I would like to tell you all about the Telegram official, Unacademy official channel on Telegram, that is Unacademy Champions, which you can join for every upcoming notifications, the notifications about the live classes, important updates about your board exams, and many more. The link is in the description box, which you can click and join this channel. So please do join the channel for every updates and notifications. Also, do not forget to subscribe us on YouTube and hit the bell icon so that you receive the notification of every class as soon as it goes live. Okay. So, if you are there in the class, please let me know if I am clearly audible and visible. And I hope all of you have appeared for this 23rd examination. And all of you, please do appear for 29th January examination so that you can be eligible. You will be eligible to win this 20 lakh rupees as your college grant. Okay, so please let me know how many students are present in the class. Yes, okay. So in this session is all about your one shot on alkanes, alkenes and alkynes. So we will do this all the three topics in one short session. So whatever we have studied, we will just cover all the important topics from these chapters. Okay. Okay, very sorry. Okay, so all of you ready? Yeah. Okay, so let's start now. So we will start with your alkanes. Okay, so now what are alkanes? So let me start with alkanes. So what are alkanes basically? So your alkanes are those compounds which have single bond between carbon-carbon atom. Yes, single bond between carbon-carbon atom. Yes. Next thing is that they are saturated. We have already covered this thing that alkanes are your saturated compounds. That means they are very much least reactive. They do not wish to participate in reaction. Okay. Next is thing that the general formula for alkanes. Okay. Now what is the general formula for alkanes? This is CnH2n plus 2. We have already seen the general formula for alkanes, alkenes and alkynes, and I hope it is clear to everyone, and if anyone is having doubt, please let me know. Okay. Now these alkanes. Okay, first of all, about which alkanes we are going to discuss. So there are so many alkanes, but we will be discussing about the first two members of this alkane family, that is your methane and ethane. So when n is equals to 1, that means only one carbon is present in your alkane. So the formula comes out to be CH4 and this is your methane. Okay, the first member of your alkane family. And if we have two carbons in the compound, the formula comes out to be C2H6, which is your ethane, second member of alkane family. Both of these members exist in gaseous state. Okay, they exist in gaseous state. Clear everyone? Also, both are found in marshy area where your organic compounds are getting decomposed. Okay, so where these both are found? They both are found in marshy areas. Okay, both are found in marshy areas. Very sorry. Very sorry. So both are found in marshy areas where organic compounds are decomposed. Clear? Yes. So these are your alkanes. All about your alkanes. So we will now talk about the preparation of methane and ethane. Just give me a moment. Okay. So very sorry students. Okay. Now let's talk about the preparation of methane and ethane. Okay. So preparation of methane and ethane. Okay. Okay, Varsha, thank you so much. Okay. So how do we prepare this methane and ethane? So first method is your preparation from sodaline. Okay, preparation from sodaline. Okay, now what is this sodaline? Sodaline is nothing but the mixture of sodium hydroxide and calcium oxide. Okay, in the ratio 3:1. Okay, so how do we do this? We take a sodium salt of carboxylic acid. Okay, so what we take? Sodium salt of carboxylic acid, and we take soda lime, and we heat it at 300 degrees Celsius. So what happens? Your sodium carbonate and alkane is formed. Okay, sodium carbonate and alkane is formed. So this is the first method of preparation of methane and ethane. So what is this sodium salt of carboxylic acid? So we will have this carboxylic acid CH3COO and we will have sodium attached to it. So let's take sodium ethanoate. Okay, this is your sodium ethanoate, or you can call it sodium acetate. We react it with soda lime mixture at 300 degrees Celsius. What will happen? This Na and this NaO will get combined. Very sorry. So what will happen? This side Na and this side NaCOO, that is Na2CO3, will get out of this, and what will happen? This CH3 and this H will be left. Yes, this CH3 and this H will be left, and both will combine to form a methane. Yes, CH3 and one H. So both will combine to form methane. So like this we can prepare methane using the sodium salt. Now in this reaction, what is removed here? Here carbon dioxide is removed. So this reaction is also known as decarboxylation. Okay, so this reaction is known as decarboxylation. Okay, so decarboxylation reaction, because the carbon dioxide is getting removed here from the sodium salt of carboxylic acid. Okay, due to the removal of carbon dioxide from sodium salt of carboxylic acid. Clear? So in this way we can prepare your methane from the sodium salt of carboxylic acid. Now if you want to prepare methane, so you can see two carbons were there. So from two carbon salt we can prepare one carbon alkane. Yes. So if you want to prepare your two carbon alkane, so we need to use 3 carbon salt, sodium salt. So we can use here CH3CH2COO Na. That is your sodium propanoate. Yes, sodium propanoate we will use, and we will again react it with sodium hydroxide and calcium oxide, that is a soda lime, at 300 degrees Celsius. What will happen? Na2CO3 will come out. Yes, Na2CO3 will come out, and your CH3CH2 is there and one H is there, so they will combine to form your CH3CH3, that is your ethane will be formed here. Okay, so these are your preparation methods. First preparation method of your alkane, that is your methane and ethane. Let's talk about the second preparation method, that is from alkyl halide. Okay, so from alkyl halide. So what we do with alkyl halide? We take our alkyl halide like we are taking iodomethane and we react it with nascent hydrogen. Okay, nascent hydrogen means hydrogen in the atomic form. So from where do we get this nascent hydrogen? By reacting zinc with dilute HCl. So this reaction will produce your nascent hydrogen. Okay, so this nascent hydrogen will substitute iodine from this alkyl halide, and what will be formed? Your methane and HI will come out. Hydrogen iodide will come out. Okay. Hello Vikrant, welcome to the class. Okay, is it clear? So this is your second method of preparation of alkane. So Vikrant, in today's class we are doing one shot on alkanes and alkenes. So if you have any doubt, please let me know. Okay, now here instead of iodine we could have used your chlorine, fluorine and bromine, but here we are using your iodide only, alkyl iodide only, because iodine is very easy to remove as compared to your chlorine, bromine and iodine. Okay, okay Vikrant. So this is your, like if we take CH3, CH2I, this is your ethyl iodide, and if we again react it with nascent hydrogen that is produced by reacting zinc and dilute HCl, what will happen? Your HI, hydrogen iodide, will be formed, and C2H6, that is your ethane, will be formed in the form of gas. Okay, so this is your second preparation method of methane and ethane. Now we will study about one particular method for methane and one particular method of preparation for ethane. Okay, now let's talk about those methods. So first method is from metal carbide. So we can use metal carbides also to prepare your methane only. Okay, so this method is used for preparation of methane only. Okay, so what is your carbide? C4 minus. This ion is known as your carbide. Okay, so let's take a carbide, like we are taking aluminium carbide and we are reacting it with steam. Okay, so what will happen? Your methane gas will be formed, your aluminium hydroxide precipitate will be formed. Okay, and the precipitate of aluminium hydroxide will be formed here. So I suppose everything is clear to everyone till now, and if you have any doubt, please let me know. Okay, so this method is particularly, or you can say exclusively, used for the preparation of methane. You cannot prepare ethane from this process. Now there is another method known as Wood's reaction, which you will study in detail in standard 11 also. So Wood's reaction is only used for preparing, okay, this is used for preparing carbon compounds having even number of carbons. Okay, carbon compounds having even number of carbon. So if any carbon compound is having even number of carbon, this method will be useful to prepare that hydrocarbon. So basically your ethane is also such a hydrocarbon which is containing even number of carbons. So you can prepare ethane from this reaction. How can we do that? We will take 2 molecules or 2 moles of your alkyl halide, okay, in such a way. So like we are taking methyl chloride, 2 moles we are using, 2 molecules we are using, and what we are doing? We are using 2 moles of your sodium also. So what will happen? We will make this reaction to happen in presence of diether. Okay. Okay. And what will happen? This sodium will have high affinity for this chlorine and it will take out the chlorine. Okay. It will take the chlorine and come out as NaCl. Okay. 2 NaCl, and you will obtain CH3, that is your ethane. So I hope it is clear to everyone. Varsha, Vikrant. Yes. So everyone, it is clear. So this is your Wood's reaction, specially used for preparing such hydrocarbons which have even number of carbons. So it cannot be used for preparing your methane. Methane cannot be prepared from your Wood's reaction because we always take 2 molecules of your alkyl halide. So methane contains only 1. That's why we need to take only even number of carbon atoms. Okay. Can we write acetylene instead of ethane? Will we get marks? Vikrant, that will depend. Okay, if it is asked to write only the IUPAC name, then in that case you need to write ethane only. Okay, but if it is not mentioned such thing, so you can write acetylene. That is also okay, but that is a common name, not IUPAC name. Okay. Thank you, Abhishek. Thank you so much. Okay. So clear, everyone? So I would like to tell you that there are certain IUPAC names, means every compound will have IUPAC name and common names as well. Okay. Some compounds have their common names more popular than the IUPAC name. But if in exam it is particularly if it is mentioned that you need to use your IUPAC name only, then in that case common name will not fetch you the marks. Okay. Okay. So this is all about the preparation of your methane and ethane. First we saw the preparation using the soda-lime mixture and your sodium salt of carboxylic acid. Heating that mixture at 300 degrees Celsius will give you your alkanes and sodium carbonate. Second was from the alkyl halide. So we react alkyl halide with nascent hydrogen, which will again give you the hydrocarbon, that is your alkanes. Third is from metal carbide. It is exclusively used for preparation of methane. No ethane can be prepared from this method. So what we do, we take a metal carbide, we react it in presence of steam to produce your alkane. Okay, that is your methane. Now we have Wood's reaction. So in Wood's reaction also your alkyl halide is made to react with sodium in presence of dry ether. Dry ether is acting as a solvent over here because every reaction needs a solvent to occur, that is needs a medium to occur. That's why we are using dry ether as a solvent. This is non-polar in nature, so it will not interact with the reactants taking part in the reaction. Okay, so this is all about your Wood's reaction. So I hope Abhishek, Vikrant and Varsha, it is clear to everyone in the class. Yes. So we generally prepare your symmetrical alkanes using this Wood's reaction, and I hope everything is clear to everyone. Now let's talk about the properties of alkanes. Okay, properties of alkanes. One thing you must know that we have a common name for methane also. We call methane as marsh gas. Yes. Kolb reaction. Abhishek, that all these things are in your organic chemistry of standard 12. We don't have to study this in our syllabus. Okay. So all these Kolb's reaction and all, this is you will study in standard 12. Okay. So we will start with your properties of alkane. So are you all ready? There is any doubt in anybody's mind? Yes, let me know please. Okay. So we will start with your properties of alkanes. Now first property is that it is very much least reactive. Okay, very least reactive. Why? Because these are saturated compounds having single bond. Okay, so as these are saturated compound having single bond. Okay, that's why they are known as paraffins also. Par means very little, affins means affinity. So they have very little affinity for other reactants. Okay. Now, Kolb's reaction you are only telling na Abhishek? What you are telling? No, ma'am. Because Kolb's reaction is utilized in preparation of your ethane. Okay, means ethane can be prepared by your electrolysis of salt like sodium acetate. So this is your Kolb's reaction. So this is in class 12. Yes, you have to study in class 12 Kolb's chemical reaction. Anything else you want to say? Okay. Abhishek, ma'am, which state you belong? I belong to Jharkhand, Abhishek. Okay. Okay. So you need to study Cole's reaction that you will read in. This is also a type of carboxylation reaction only. So we will study this in your standard 12 organic chemistry. Okay, Cole's chemical reaction that you will means understand in standard 12. Okay, understood everyone? So we need to study the properties of alkanes, that is your very least reactive because they are saturated compound, they have single bond. Okay, now second is that they give substitution reaction. Now you need to study, you have to study the substitution reaction. So what is this substitution reaction? Okay, so you will study all these things in very much detail in standard 11, means what is the entire mechanism behind this substitution reaction. But in this class you will only have to study how this reaction takes place. Like substitution, what does this word suggest? Means something is getting substituted from the hydrocarbons. So what will we substitute? Of course carbon will not be substituted, so you need to substitute your hydrogen only. Okay, ma'am, should we take ICSE or CBSE for class 11 and 12? Vikrant, my opinion is that you must take CBSE for class 11 and 12 because ICSE class 10 means ICSE is good, very good for class 10. Till class 10 it's okay. But for JEE and NEET and means competitive exams of 12th standard, you need to have the knowledge of your NCERT textbook because the competitive exam syllabus is based on NCERT. Okay, so CBSE is better than ICSE for 11 and 12, and of course till 10th standard ICSE is the best. Okay, clear everyone? So I hope it is clear. Okay. So they give substitution reaction. Now what type of substitution reaction? Like chlorination of methane. So we need to study some two types of substitution reaction, that is your chlorination of methane and chlorination of ethane. In similar way your bromination will take place, in similar way your iodination will take place. Okay, so here we will study only about your chlorination. Similar reactions will be with bromine, iodine also. Okay, now what is this chlorination of methane? So we will take methane, we will take chlorine atom and we will keep this mixture in diffuse sunlight, or you can heat this mixture at 600 Kelvin also. Okay, so what will happen? We are using this sunlight to break the bonds between chlorine and chlorine atom. Okay, so this sunlight is used to break the bond between chlorine and chlorine atom. Okay, so what will happen? This chlorine and chlorine atom bond will get broken down, and what will happen? This one hydrogen will come out of this methane. So what will happen again? See, 4 hydrogens were there earlier. 1 hydrogen has come out and combined with this chlorine to form your HCl, and 1 chlorine will go and take the place of hydrogen that has been left by your hydrogen atom. Okay, so in this way the first product that we get by the chlorination of methane is your chloromethane. Okay, so this product is formed when you do the partial substitution of methane. Okay, partial substitution of methane will give you chloromethane. Now this reaction will not stop here, it will continue. So how it will continue? Like CH3Cl we have got, again it will combine with chlorine present in the mixture to give you HCl. HCl will be taken out, again 1 more hydrogen will get substituted by chlorine and the number of chlorine atoms will increase. Again this reaction will further proceed and again your HCl will be out, okay, in presence of your chlorine, and 1 more chlorine will increase and the number of 1 more hydrogen will decrease. So this is like CHCl3, that is your trichloromethane. Okay, trichloromethane has been formed here. The common name of this compound is chloroform. The common name of this compound is your chloroform and the IUPAC name is trichloromethane. Now this reaction won't stop here, again it will continue and again HCl will come out in the presence and Cl2 is there. So in the presence of sunlight, again one more H will be substituted by this chlorine atom to form your CCl4. So this substitution reaction will continue to go on till your every hydrogen present in the hydrocarbon has been substituted by the halogen. So here you can see 4 hydrogens were present in methane. So all the 4 hydrogens have been substituted by the chlorine atom. That means the reaction will stop here, and this is your final product formed in the chlorination of methane, or you can say this is the final product of complete substitution. Okay, this is the final product of complete substitution. Is it clear, everyone? So Vikrant, Abhishek, Varsha, please tell me if it is clear to everyone. Yes. So this is your tetrachloromethane. Okay, this is your tetrachloromethane. If you talk about this IUPAC name of this compound, this is your tetrachloromethane. Okay, and if you talk about its common naming, so every compound has a common name, but some have their common names more popular than IUPAC name. Okay, so common name is carbon tetrachloride. Okay, carbon tetrachloride. Clear? So this is all about your properties of alkanes. So in substitution reaction, we saw the chlorination of methane. Similarly, we can have chlorination of ethane. Okay, similar way we can have your chlorination of ethane. So what happens in chlorination of ethane? So we take ethane. Again, we will add chlorine to it in presence of diffuse sunlight. One H will come out and combine with chlorine to form your HCl. One chlorine will go and get attached to this ethane compound and it will form C2H5Cl. This is your chloroethane. Yes, after this again your chlorine atom will go. HCl will combine and one more chlorine will come out, and what will happen? C2H4Cl2 will be formed. That is your dichloroethane. Okay, now after this what will happen? Again this reaction won't stop here. Chlorine atom is there, HCl is there, C2H3Cl3 will be there. Again the reaction will not stop here. Cl2, HCl will come out. So C2H2Cl4. This will be the compound. Okay, C2H2Cl4. So this is your trichloroethane. This is your tetrachloroethane. Okay, now this reaction won't stop here. I told you the chlorination reaction or the substitution reaction, okay, does not stop till all of your hydrogen present in the hydrocarbons get substituted by the halogen. Okay, so what will happen now? Again this C2HCl5 will be formed. Okay, so this is what your pentachloroethane. Okay, pentachloroethane. And after that again Cl2 will add, HCl will come out. So it will be C2Cl6. Okay, C2Cl6. This is your hexachloroethane. Okay, so this is all your chlorination of ethane. In similar way your bromination will take place, iodination will take place. I hope it is clear to everyone. Please let me know if it is clear to everyone. Vikrant, Abhishek, if you are there in the class, please reply, and Varsha. Okay, now we will talk about your combustion reaction. Okay, now what is this combustion reaction? So basically nothing is there. If you burn hydrocarbons in presence of excess of air or oxygen, they will produce carbon dioxide, water and heat and light. Okay, so if we take methane and if we burn them in presence of excess of oxygen, this is your excess of oxygen. So what will happen? Carbon dioxide, water and heat and light will be produced. Okay, so this is your combustion reaction. Similar thing will happen if you take like ethane. Okay, ethane if you take, so oxygen they will combine and again your carbon dioxide, water and heat will be formed. So let's try to balance this equation. 7, 2, 3. Okay, now the flame that is produced during the complete combustion, this is what? This is your complete combustion. Any combustion taking place in presence of excess of oxygen to produce your carbon dioxide and water is termed as your complete combustion, and the complete combustion, the flame is non-sooty in nature. So in this case the flame will be non-sooty in nature. Okay, the flame is non-sooty. Just let me. Okay, that means clean flame will appear of pale blue color. But if you keep the supply of oxygen insufficient, then what will happen? Your carbon monoxide will be formed. Okay, so carbon monoxide and water will be formed if your oxygen supply is insufficient. Okay, so flame will be like sooty. Yes, so this is the combustion reaction in which your alkanes and alkanes such as methane and ethane participate. Okay, I hope it is clear to everyone in the class. So here it comes to the end of your alkane reaction. Properties of alkanes and reactions of alkane and preparation method of alkanes. Now let's talk about before talking about the preparation method of alkanes, I would like to tell you about the Unacademy subscription features. So with Unacademy, you can learn live from the comfort of your home. You can have unlimited access to all the courses. Top educators of India are teaching on this platform. You will be having regular doubt solving sessions. Your every syllabus, every topic of the syllabus will be covered if you take the Plus subscription. You will be provided mentorship and guidance. Study material in PDF format will be provided to you. Practice tests are there. Live test series are there. Batches and courses. So many things are there. Amazing facilities are there which you can have access if you take the subscription. And all these things will be provided to you with just a single subscription. So if you are in class 10, we have started a batch called Mavericks, where your India's top educators are taking the classes and the mode of teaching is in English. So if you take the subscription for class 10, you will get the subscription for 11 and 12 just for free. Okay, so please, if you want to kickstart your preparation for board exams, please do not miss the opportunity to join this Plus subscription and meet us in our class so that we can study everything conceptually. We can clear all your doubts so that you don't have any doubt while you go in the examination hall. Also, we have a batch called Param, where the mode of teaching is in Hindi, and a new batch has started also, that is your Udan batch. So with single subscription, you can enroll in yourself in any batch. Okay, in any batch you can enroll. Clear everyone? And we have Plus subscription starting from 3 months to 48 months. So for whatever period of time you want to take, you can take the subscription. But do not forget to use my code Manisha Live, which will fetch you 10% discount. Okay, give me a moment. Okay. Also, we are having an offer now that if you take the subscription for 1 year and more than that, you will be provided extra 6 months subscription. Okay, extra 6 months subscription if you take the subscription for 1 year and more, and that too before 27th of Jan. Okay, because we have this offer till 27th of Jan, so please do take the subscription as soon as possible. Okay, now we will start with your alkenes. Okay, now what are alkenes? The compounds which contain double bond between your carbon-carbon atom. Yes, between carbon-carbon, carbon and carbon atom. So if you see a double bond, that is your alkene. Now what is the general formula of alkene? CnH2n. This is your general formula for alkene. Yes. Now, if we want to know how many what is the molecular formula of an alkene? So which is the first member of your alkene family? Can you tell me? Which is the first member of your alkene family? Yes. Vikrant, Abhishek, anybody is there in the class? Okay. So CnH2n. So if we take, so N is equals to 2 has to be there because the first member of alkene family is ethene. Less than that, nothing you can be there. Methane cannot be there because only single carbon is present in methane. So it cannot form double bond between carbon-carbon atoms. So yes. So we will have N is equals to 2. So ethene formula we receive C2H4. This is your ethene, first member of alkene family. Okay, this is the first member of alkene family. Yes, just give me a moment, everyone. Okay. Okay, so this is your first member of alkene family. Now, these are which type of compounds? These are your unsaturated compounds. Okay, these are your unsaturated compounds. Okay. Hello, Abdullah. Welcome to the class. Okay. So, methane. What you are writing methane, Abdullah? For what? Because we are talking about alkenes. The discussion for alkanes is over. Now we are talking about alkenes because this is a one-shot session on your alkanes and alkenes. Okay. Okay. So this is your ethene and the common name for ethene is ethylene. Okay. The common name for ethene is ethylene. These are your unsaturated compounds because of the presence of your double bonds. Due to presence of double bonds. Okay. So these double bonds make these compounds very reactive in nature. So alkenes are basically more reactive than alkanes. Okay. Now we will talk about the preparation of your ethene or ethylene. So how do we prepare this ethene or ethylene? So preparation of ethene, or you can call it ethylene. So first is from alkyl halide. Okay, so first is from alkyl halide. So alkyl halide are also known as haloalkanes. Haloalkanes. Okay, so like if we take this is your haloalkane. Yes. Now if we react it with KOH, concentrated and alcoholic. It is important to write concentrated and alcoholic with KOH because if you will not write, some other reaction will take place. Okay. So we take an alkyl halide, we take concentrated and alcoholic KOH solution and we react it. What will happen? This HBr will come out and the Br will get combined with this potassium to form KBr, potassium bromide. And this H will combine with OH to form your water molecules. And since both of these two atoms are removed, so what will happen? Your carbons will form a double bond. Yes. Carbons will form a double bond. This is your ethene. Yes, this is your ethene, or you can call it ethylene. Yes. And how it is collected by downward displacement of water. Now, here what you can see that your one hydrogen is removed, one halogen is removed. Okay. So, the removal of one hydrogen and one halogen. So, what will be name of this reaction? Dehydrohalogenation. Okay. The name of this reaction is dehydrohalogenation. D means removal, hydrogen, halogenation means halogen. So, that is your removal of hydrogen and halogen. Clear? So this is the first method of preparation of your alkene, that is your ethene. I hope it is clear to everyone. Second preparation method is from alcohols. Okay. Now we take an alcohol and we react it with sulfuric acid, that too in the concentrated form at 170 degrees Celsius. What will happen? Your sulfuric acid is a strong dehydrating agent. Okay, it is a strong dehydrating agent. So what will happen? It will take out this water molecule, and now both the valencies of carbon are free. So they will form a double bond, and hydrogen, 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 hydrogen. Like this it will be formed. So since there is a removal of water in this reaction, and ethene is formed by removal of water, this reaction is known as dehydration of alcohol. Okay, dehydration of alcohol. Clear everyone? Yes? So just give me a moment everyone. Okay. So I am back. So here the water is removed from the alcohol molecule. So this is your dehydration of alcohol. So these are the two preparation method of your alkenes. Now let's talk about the properties of alkenes. Okay, what are the properties of alkenes? First of all, though, they are unsaturated compound. Okay, now they are unsaturated compound. Like alkanes were saturated once and they showed substitution reaction. So your alkenes are unsaturated compounds and they will show your addition reaction. What they will show? They will show your addition reaction. Okay. Now, what is this addition reaction? Let's understand. Something is added. From the name itself, we can understand something is added. So we can see three types of addition reaction over here. Okay. Okay. So we can see that we can have three types of addition reaction here. First is your addition of hydrogen. This addition is known as hydrogenation. Okay, hydrogenation. Now what we will do? We will take this alkene. We will react it with hydrogen in presence of nickel at 200 degrees Celsius. Nickel is a catalyst used here. So what will happen? This bond will break and your alkane will be formed. Okay. Hello Rajat, welcome to the class. At what this will end, ma'am, because I have joined now. Rajat, this will end at 11 o'clock because this class has started at 10 o'clock. Okay, so usually the chemistry classes for class 10 starts at 10 p.m. on this platform. Okay, so you can watch the class for 15 more minutes and then you can watch the recorded session of this class. Okay. So here you can see this bond has broken and those two hydrogen have come and they have got attached to these two carbons to form your saturated compound. That means your unsaturated compound has been converted to a saturated compound. Okay. No Rajat, we don't have classes daily. The classes are on every alternate days. So today is Wednesday and we are having the class. So tomorrow we won't have any class for class 10. Then we will have our class on Friday. That is your 28th. Sorry. Yes, 28th of January 10 p.m. Okay. So we don't have classes every day. It is every alternate day. Okay. Okay. So here you can see that ethene is converted to ethane. This is your ethene and we have converted to ethane. That is saturated. How? By reacting it with hydrogen in presence of nickel at 200 degrees Celsius. So if you, instead of nickel, if you use catalyst like platinum or palladium, the temperature does not require to be so high. You can carry out this reaction at ordinary temperature also. Okay, so double bond breaks here and they get converted to your alkanes. Clear? Because these are your platinum and palladium are your strong electrolytes. I hope it is clear to everyone. Now let's talk about the second type of your addition reaction, that is your addition of halogen. Okay, addition of halogen. Okay, now what is this addition of halogen? That we add a halogen over here. So let's suppose we are adding bromine to this alkene. Okay, we are adding bromine to this alkene in the presence of CCl4, that is your carbon tetrachloride, which is a non-polar solvent here. So what we will do here? We will take this and this bond will again break. The bromine both will come and they will get attached to this alkene to form your 1,2 dibromoethane. 1,2 dibromoethane, or you can write the common name as ethylene dibromide. Okay, ethylene dibromide. So this is the reaction taking place here. Now this reaction will also act as a test for your alkene. This reaction also acts as a test for your alkene. So what is the test? So this bromine, when it is in your CCl4 solution, the color of this solution is orange. Now the compound that is formed here, it is colorless. Okay, so if you change the, if you are observing the change in color, that is from orange to colorless, you can identify, yes, the reactant that we have put into this solvent is your alkene. Because alkenes will only give this reaction, your alkanes will not give this reaction. Yes, Rajat, brown color of bromine discharge serves as a, not brown, orange basically. Okay, so orange color of this solution will be converted to your colorless. Okay, so this is a test for the saturation that your unsaturated compound is present here. Clear everyone? Tell me fast. Yes? I hope it is clear to everyone. Okay, so orange will turn to colorless and this reaction will be given by your alkenes and alkynes and no alkane will give this. Okay, so this is a test for your alkene. Okay, very good, Rajat. Now next, your addition reaction is addition of Bayer's reagent. Now what is this Bayer's reagent? Let us just understand this. So if you take potassium permanganate KMnO4 in dilute, cold and alkaline form, okay, dilute, cold and alkaline form, this is your Bayer's reagent. Okay, now the color of this reagent will be pink or purple. In some book it is given pink, some books have purple. So we will take both. So pink or purple can be the color of this reagent. After this, we will do what? We will react alkene with this cold, alkaline and dilute, cold, dilute and alkaline KMnO4. Okay, so this is a OH supplier. Okay, this potassium permanganate, that is your Bayer's reagent, acts as OH supplier. Means its function is to supply OH to organic compounds. So what will happen? It will supply two OH molecules which will come. This bond will get again broken. So what will happen? So two bonds on each carbon will be left free which will be formed, means which will be acquired by this OH molecules. Now again you can see the alkenes are converted to your alkane, and the name of this compound in IUPAC will be ethane 1,2 diol. Okay, ethane 1,2 diol. Now the test is that the pink color of Bayer's reagent will change to colorless because the product that is formed here is colorless. Okay, so the change of pink color to colorless is again a test for your saturation, that is your alkene is participating in the reaction. If the color does not change, that means your alkanes are present in the reaction, because no reaction will happen here. Clear everyone? Tell me fast. Yes? Rajat, Abhishek, Vikrant, Varsha, everyone please tell me if it is clear to you. Ma'am, are you teaching ICSE reduced syllabus? Yes, Rajat, I am teaching ICSE reduced syllabus, and in reduced syllabus also you have addition reactions. That's why I am teaching this. Addition of hydrogen, addition of halogen, and this addition reaction with your alkenes. Test for your alkenes. Okay? Okay. So here we come to the end of our alkenes part, and I hope it is clear to everyone. Alkene part is clear to everyone. The test for alkenes addition reaction is clear to everyone. One more addition reaction is also there, which I should discuss with you. Like if we are taking ethene and we are reacting it with HCl, what will happen? This bond will break and one H will go and get combined with this carbon atom, one chlorine will go and combine with this carbon atom, and this is formed. Okay, so this is what here your addition of hydrogen is taking place and addition of halogen is taking place. So this reaction is known as hydrohalogenation. Okay, so this addition reaction is known as hydrohalogenation because your addition of hydrogen and halogen is taking place. Okay, Rajat, you have chemistry class test tomorrow. So what is your syllabus for your class test? Organic chemistry? Okay. So I hope it is clear to everyone in the class. Let's talk about now alkynes. Okay, now what is alkynes? If triple bond is present between the two carbon atom, that is your alkyne. General formula is CnH2n minus 2. Okay. The first member of alkyne family is ethane having formula C2H2, where n is equals to 2. That means number of carbon atom will be 2. This is your ethane. Okay. This is your ethane and the common name is acetylene. Okay. The common name is acetylene. Okay. Everyone understood? Now this is which type of gas? This is odorless. Okay. But again it is found in garlic odor. Now at one point I am telling it is odorless. Again in another point I am telling that it is found in garlic odor. So why this is found? Due to the impurities of phosphine. This garlic odor is present due to the impurities of phosphine. So pure ethane gas or acetylene gas is odorless. Clear everyone? Yes? Now let's talk about the preparation method fast. That is from calcium carbide. Okay, just give me a moment. Calcium carbide like CaCO2 we will take, and we will take it take water. So what will happen here? This is the compound. Okay, this is the compound. So CaOH whole twice and this C2H2 will be formed. This is your ethine or acetylene. Clear everyone? Rajat, Umar, Vikrant, Abhishek, Varsha, clear? Okay? Now okay. So, this was your first preparation method of alkynes. Second is your preparation from 1,2 dibromoethane. Okay, Rajat. Dibromoethane. So what will happen? We take like dibromo. Okay. Now we are taking it like this and we will react it with alcoholic KOH. So what will happen? The HBr will get removed from here. HBr will get removed from here. And what will happen? Your acetylene, that is your ethine, is formed and KBr and water molecules will come out. Okay. So this is your very sorry. This is your elimination reaction. Okay. This reaction is known as elimination reaction. Because what is eliminated? Your hydrogen and halogen is being eliminated from the compound. So this is termed as your elimination reaction or dehydrohalogenation reaction. Clear everyone? Rajat, is it clear? So anyone is having any doubt, because we will end our class till here only. Okay? We are going to end our class here only. So if anyone is having any doubt, he or she can ask me. I suppose this is not clear. The products are not clear here. So I am just writing it again. So these are your products form. Okay, Rajat, very good. So the upcoming special classes on Unacademy app, like tomorrow we have study of compounds on poles we have. Then on 29th we will be revising your hydrocarbons again via poles. And my special classes are at 4 p.m. I got to know about this channel now. Okay, Rajat. So do join the classes at time. You can also join the classes for chemistry, physics, maths, biology on Unacademy app also in the special classes, which is for free. Okay, these classes are for free. You just need to download this app. Okay, and through special classes, you can have real-time interaction with me. You can participate in the live quiz through polls. You can compete with the friends. You can ask questions. You can ask your doubts. Okay, so along with this channel, you can also attend classes on the app. So how can you watch my special classes? You can download the Unacademy Learner app. Open the app and click on Get Started. After that, enter your phone number. OTP will come. Enter that OTP and sign up using your email ID. Choose your class as ICSE, goal as ICSE, class as class 10, and then language you choose, and you can watch all the special classes that are just for free. Do not forget to use my code Manisha Live. This will unlock all the free classes for you and you can watch the classes on Unacademy app also. Okay, Rajat? So I would like to invite you all to the Unacademy app and watch the special classes as well along with the YouTube classes. Okay? And if you are really liking this channel, if you're really getting benefited from the classes, please do share the classes with your friends also, so that they can also join us on this platform. Okay. So Rajat, if you are really liking the channel, the way of teaching, the teachers and all, you can watch the classes on special class also. So I would like to end my class here only. So this was all for today's class, and we will again have our class on 28th of January at 10 p.m. Do not forget to join that class. Also, please subscribe to the channel and hit the like button. Okay. So thank you all for watching the class live. I hope you enjoyed the class, and do watch the special classes on Unacademy app. Also, do not forget to download the app. Okay. So bye everyone. Thank you so much for your time. Good night, and let's meet on 28th January 10 p.m. Okay.